And yes. So it has to be proctor, which means that somebody has to watch you while you um actually take it. So the options are to take the test in the testing center here on campus, and that's free, but that only works if you're local. If you want to use a third party proctor, that could be somebody, somebody that works at a technology center or another college or another institution. It cannot just be a private individual that you know. But if you want to use that, then email me and I will send you the proctor agreement form. But that's probably also free, but you're limited to the times when that person can actually proctor your exam. So that's why there is a third option, and that's ProctorU. ProctorU does cost you money, but technically, if you wanted to take the final exam, say on Saturday at 11 p.m., because that works better for you, ProctorU can accommodate you. However, ProctorU requires an appointment. So, and the closer you are to this date here, the more expensive it gets. And they may not have an appointment the exact time that you want if you wait until close to that time. So, if you are using ProctorU, please make sure that you make that appointment as soon as possible. It gets more expensive and you may not get the appointment that you want. For those of you who log in a little bit late, I'm going to take attendance at the very end also. So please do not disconnect your camera. Do not disconnect until I've told you I've taken pictures of the attendees. Okay. You are allowed to use a 3x5 note card. That's about the size of a regular cell phone. You can use front and back. Remember, that's really like 5 points out of the 100 points for the test. So you have to turn it in. If you do not turn in your note card, then it's 5 points automatically deducted. So if you are in the testing center, then you will have to turn it in there. If you're using a different proctor, you will send that. You can send pictures of your note card, um, uh, via the Canvas inbox or my email. And um, you can send it to me different ways, but I need it actually by the next day by 8 a.m. The next day on December 16th. That also reminds me of the scratch paper. I review every chapter test, and I review the proctor midterm and the proctor final for sometimes formatting errors, sometimes rounding errors. I give you partial credit in when Sophia doesn't really give you any partial credit. But there are other times when the answer looks completely different, but if you have turned in your scratch paper with problems number, then I go back only if something is wrong. I go back to your scratch paper. I see if there is work for that particular question. And if you were on the right track and you made a mistake, I can give you partial credit. But again, I need that scratch paper by 8 a.m. on Tuesday, December 16th, because I have a deadline myself to actually turn in your grades. So remember, the final exam will close at 5 p.m. on Monday, December the 15th. It will open at 7 a.m. on Thursday, December 11th. I need the note card and the scratch paper by 8 a.m. on Tuesday, December the 16th. Okay, so let's go now to the actual document and review that we have. And there are 35 questions. I'm not sure that I'll be able to look at every single question, but I have gone through almost every problem and I have identified some formulas that you will need. So I want to concentrate on that to help you with your note card. And then once we've done that, then if there's time to look at a particular question, I'd be glad to. So in this first question here, the you have to do the frequency, and one of the first things you have to make sure you find is the range. And the range is the maximum entry minus the minimum entry. That's a minor thing, but it's very, very important. Then the class width, that's the range divided by the number of classes. And one thing that I want to point out to you is that you always round up this number. So for example, if your class width ends up being 18.3, you still round it to 19. If it turns out to be 18.8, it makes sense for us to round it up. But you round it as long as it has at least one digit in a decimal place, you will have to round it up regardless of what it is. Okay, so I'm gonna go to, and so this one was question 1. So if you are logging in late, I will take attendance at the end and make sure that your camera works for me to give you your attendance points. Also, if you notice you have missed some information, when I post the recording, make sure you watch what you have missed here. So this one is question number 2. And I'm concentrating on the ones that I've noticed actually require a formula. So this next one is number 3. And I missed, I went back, I went too far. Okay, so number 4. This is called a 5-number summary. And I think the minimum and the maximum are kind of self-explanatory. But one thing that I want to point out to you is that when you're doing quartiles, which is really what we're doing here, you need to order the data. And that usually means from the smallest to the largest. So that would be 1.8, 2.3, 2.4, 3.2, 4.8, 8.0, and 8.3. And then you can easily find what the minimum is, 1.8, the maximum is 8.3. And that's not as important, but the median, if you have an odd number of entries, then the median is going to be the number in the middle. So that will be 3.2. In the first quartile, that Q1 would be from the first half, it will be the number in the middle or the average of those two. So this will be the first quartile. And for the second half, between 3.2 and 8.3, This one is halfway, and that will be actually your third quartile. And it's cut off, but on the next page, we have the interquartile range. And again, it's not very, very difficult, but it's something that you might forget what it is. So the interquartile range is actually the difference of the third quartile minus the first quartile. And so in this case, it was actually 8.3 minus 2 point, no, 8.0 minus 2.3, and that turns out to be 5.7. Okay, so let me see. Okay, number 7. And number 7 is actually this one here. Doesn't quite require formulas because you can actually do it on the calculator, but it will require that we enter this data. And so, and it actually continues on the next page. So that's going to take us a little bit of time, but in order, what they ask you to do is to find the range, the variance, and the standard deviation. The variance and the standard deviation, or mainly the standard deviation, can be found directly by the calculator, but the range, you actually want to enter the data and you want to sort it, you want to order it. So we're going to use that stat key of the stat menu of the calculator. We're going to use edit, which is option 1, and we're going to enter this data. So I might as well enter what you see here on this page. Let me make it a little bit bigger. And then continue with the next rows of data. So I'm going to go ahead and enter that on the calculator. So I go to stat and edit. I'm going to go ahead and go to L1, clear, and enter. You may not have data here, but I did move to L2, clear, and enter. And so now I'm going to start entering all the data in L1. And it is tedious, but it's a lot better than having to order it yourself. And to find the range, you have to order it or find the smallest and the largest one, the maximum and the minimum. So I'm going to put, and I already made a mistake. And I think I made a mistake on this one. It should be 3, 4, 1. Okay, so I know this is going to take a long time. So let me show you what I would do if I only had the data that you see right here. But this actually continues on the next page and is very long. But let's say this is all the data that you have. So and it makes sense that if you have a large amount of data, then you enter it in your L1 and you're gonna sort it. So after you enter it here, you go back to stat and in the same menu edit, you sort. So it'd be number 2. You have to tell the calculator which list. So notice that the list 1 through 6 are actually in the numbers 1 through 6 as the second function. So if I go second and L1, we're telling the calculator that we're going to sort that. And it says it's done. So you go back to stat, edit, and then you can see them in order. Okay. So I know this one don't necessarily be correct, but it will save us a little bit of time. So then the range will be the maximum entry minus the minimum entry, just like it was in the previous exercise. So in this case, it will be the 35,434 minus the 7,724. And that will be what the range is. I don't want to write that because it will be incorrect since I didn't enter all the data. But what I am going to write in here is just to remind you that is the maximum entry minus the minimum entry. Okay, so you have entered your data. So now you want to calculate the standard deviation and the variance. Actually, the standard deviation, it's one that is given right away. So you go back to stat, but now you calculate and you calculate using one variable statistic. So you're going to press 1 or enter and it just double checks that the value the datas are in L1. You go down to calculate, press enter and see it does the mean. That's the X bar, whether it's a population mean or a sample mean. S, that is actually this is different. So this will be the sample. This is definitely a sample because you see a limited number here. So then, hold on a second. Let me read what it says. Actually, it doesn't say necessarily it's a sample. It says a government agency reported the number of individuals the visit a primary doctor in 50 different towns. So we're going to assume that it's a population. So then that means I want the sigma as my standard deviation. And one thing that is not given, so let me make a note here. So one thing that is not given is the variance. The variance is always the standard deviation square. So whatever this number is here is your standard deviation. Then you square that number and you find your variance. One quick way of doing that, if you go back to the operation screen, if you go to variables and statistics and you recall the population standard deviation, that will be number 4, and you square it, the calculator is grabbing the standard deviation from the data that you just calculated, and it will actually do your variance without having to round your answer. Okay, so the next couple of questions are questions that have to do with probability. This one is QA, and it's a six-sided die is roll, and we want to know what is the probability that we get a number less than 9. All the numbers on the die are less than 9 because it goes through 1 through 6. We call that the outcomes are basically are basically 1, 2, 3, 4, 5, 6. It could be that the problem that they ask you, it doesn't say 9, but it says something like less than 5. But in this case, in here, that's the total number of outcomes. So this is going to be out of 6. But every outcome is less than 9. So it's going to actually be 6 out of 6, which is 1. If the question was something like, what is the probability of getting a number that is less than 4? Then you have 1, 2, and 3. That would be 3 out of 6. Now, this next one here is another probability problem. And in this case, it says the probability of a person living in an industrialized country of the world is 1/3. Find the probability that a person that does not live in an industrialized country. So we take 1 minus this probability. This is your P. 1 because that's the total. So that would be 1 minus 1/3, and that would give you 2/3. So these ones are not necessarily formulas, but they're all kind of different in here. This one is actually a vocabulary question um, between independent and dependent events. So it says if you draw a marble from a box, but you don't replace it, and then you draw a second marble, then the options will be dependent or independent, but we need to look at the reasoning in here. Actually, they don't give you that. It will be independent, drawing that second marble. It will be actually independent from the previous one since it was not replaced. Actually, that's not true. It will be dependent because you have actually taken one choice out of the bag. Okay, the next one, that one is number number 11. So this one, it says a single card is drawn from a deck. Find the probability of selecting a 5 or a black card, and then express the answer as a fraction. So we need to calculate the probability of selecting a 5. We need to find the probability of selecting a black card, but we don't want to repeat those, so we're going to have to subtract the probability that is a 5 or a black. So there are 52 cards in the deck, and there are 4 suits. So there are actually 4 5s in the deck. So that's going to be 5 out of 52. Sorry, 4 out of 52. Now, the black is more, there are more because you have 2 whole suits that are actually black. So each suit has 13 cards, so this will be 26 over 52. And then out of the out of the 4 5s, 2 are black. So then there are 2 cards that are black and a 5. So we're gonna subtract 2 from 52. So when we subtract all of those, we get 28 over 52. Then we have to make sure we reduce it. It's a simplified, so that will be 7/13. Okay, the next one it's different, but at the same time is you're also counting um the number you're counting the number of 12 graders is your total, and you're counting how many got a 0, how many got a 1, and so on. But you're adding them to get your total. So I'm gonna skip that one. Number 12, number 13 is really more like a vocabulary question, but it's important to know what the justification for this is. It's asking you if this is a probability distribution. And by the way, when I converted those to PDFs, it actually changed that. There should be 1/5. So first of all, every one of those probabilities has to be between 0 and 1. And 1/5 is a 0.2, so that's correct. The other thing is every one of these probabilities, when I add them, when I add every single one of them, is supposed to be equal to 1. And you have a common denominator there, so that does indeed end up being 5/5, which is actually a 1. So you're checking 2 conditions here. So it does look like it is a probability distribution. So let's go to the next page, and let's make sure that we pick the correct, not just the one that says yes, but also that it gives the correct explanation. And by the way, this one just is the only one that says yes, but it says the sum of all the probabilities is equal to 1, and each of the probabilities is a value between 0 and 1. So it would be this one here. Number 14 has to do with a probability, a proportion. It says 55% of the government employees use email. If you have a sample of 100 government employees, find the mean, variance, and standard deviation. So this doesn't have to be very difficult, but it does require formulas. This is not a calculator exercise. This is your proportion. So your P is 0.55. Your Q, so that's the probability of success, and Q is the probability of failure. So it will be always 1 minus P. So in this case, it will be 0.45. So now to find the population mean, wow, I don't even know how I did that. Okay, hold on. So to find the population mean, you use the formula mu equals the sample size times P. To find the variance, then is N times P times Q. And to find the standard deviation, just remember that is always the square root of the variance. So it ends up being the square root of n times p times q. So make sure that you have those formulas, because otherwise you might be thinking that it involves maybe the calculator, but it actually involves these formulas. Now, number 15 is actually very different, because this is, in fact, a calculator exercise. They do give you a proportion. They say 32% of the couples who plan to marry in the next year, they want a destination wedding. Okay, so that will be your P. P equals 0.32. You can find your Q fairly easily. Actually, that's a 31. So you could find your Q by subtracting the 0.31 from 1, but we'll see on the calculator we actually don't need that. Then it says in a sample of 12 couples, that's your N, who plan to marry, find the probability that fewer than 5 couples one are planning a destination wedding. So you're calculating the probability that X is less than 5. And that means you want to know what is the probability for 0, what is the probability for 1, what is the probability for 2, what is the probability of 3, and what is the probability of 4. And it sounds really tedious because we're going to actually have to find that on the calculator. I'm going to run out of space here, so let me draw a line right here. I'm going to leave some room for number 16, and I'm going to continue this one in here. So N is 12, and this is called the number of trials. X is the random variable. So for example, when you're calculating P of 0, X is 0, and it is based on this binomial distribution. So this will be second vars, which is the distribution menu, and then is option A. To be honest, I don't remember A, but we want a binomial distribution. I can't remember if it's A or B. So we want the binomial distribution. Yeah, it's A. So we're going to calculate each of those. And it says to round answers to 3 decimal places. So I'm going to take 3 decimal places for each of them. But you're going to go second vars to the distribution menu. I don't see A, so if you go up, it's A. Then the number of trials, that's your N. And it looks like it's 12. My P for this particular problem was 0.31. That was my proportion that was given. And we're calculating the probability for 0. Press enter, and it gives you the decimal. And remember, we're taking 4 decimal places for this. I actually went with 5, and then I added them up to get 3. But what I wanted to show you is you don't have to repeat those steps exactly. What you can do is you can go here, press enter, and just change the 0 to a 1. So this will be the probability of x equals 1. Then keep doing that until you have all the way to 4. So change this one to a 2. Repeat it, change it to a 3. Repeat it. Change it to a 4. And then you're going to add each of those numbers. So I'm going to write them in here with 5 decimal places. So we're adding all 5 of them. So I have 0.01164 plus 0.06278 plus 0.15515 plus 0.2323 and then 0.23487. And then when you add them, it will be 0.69674. And it does say to round your answer to 3 decimal places. So then we can round that to 0.697. Okay, number 16. It does talk about, in number 16, it does talk about, starts talking about z-scores, but it's not based on areas, it's based on x values here. So it says the average amount of money paid for a full tank of gas in a certain city is 55.20. So then that's your X bar. Since it says average amount. Then it says the standard deviation is 13.30. So that's the sample standard deviation. So that's 13.30. Then it says find the scores corresponding to the following 2 individuals. Devon spent $88 on a full tank, and Jorge spent $18 on a full tank. So those are X's. X equals 88 for Devon, and X equals 18 for Jorge. So those are individual or random variable values. Now we want to change them to a z-score, and this is the formula for the z-score. Z equals x minus x bar divided by the standard deviation. So you will use that formula for each of them and change the Devon's value to a z-score and Jorge's to a z-score. Okay, so the next ones are also z-scores, but from tables. So this will be number 17. So the tricky thing about tables, I like using the calculator better, but a lot of times you are provided with a table. So the tricky part about these tables is that they're all based on positive z-scores. You're the one that decides whether a z-score it's positive or negative. So and they're all based from half of the bell shape. Let me see if I can. So what I'm saying is this area is considered zero point 0.5. So all the areas that you see in the middle of the table are less than a zero point 0.5. So you need to think hard about where this particular, um, where this z-score is going to be to actually use the table here. So it said, so this is just to tell you how the table works. Let's actually look at the information for the problem. It says find the z-score such that 67% of the area under the distribution lies to the left of that z-score. Okay, so that's a little bit different. And we're looking for a z-score, and 67% of that area is to the left of that z-score. So if half of it is 50, then, and it's going to be, and the area is to the left, then we're talking about an area bigger than 0.5. In fact, that area is 0.67. And we're looking for a z-score that is here. And this z-score is actually a 0 for the half. So this is why on the table things are complicated, is because you're not looking for an area that is 67. You're looking for this area here in the table. So on the table, the area will be 0.67. That's the whole area that I have kind of, dash or have the lines. 67 minus 0.5, that gives you 0.17. That's the area that you're looking for in here. Let me make it bigger or as close as possible. So I'm looking for 0.17. So I start seeing some teens in here. And I find exactly 0.17. So that will be a z-score of 0.4. And the second digit will be 0.44. Now, let me show you how I will do this on the calculator. On the most calculators, especially the one that we have, only or they actually consider areas to the left of the z-score. So I prefer the calculator because when I'm looking at an area, when it says the area is 0.67 to the left, and I look at the graph, 0.67 will be here, and that's truly the area that I use on the calculator. And I'm looking for the z-score. Now, what I use is I use second bars option 3. However, I'm going to warn you that if in Sophia they give you a table, if I were you, I will do it with the table and check it with the calculator, because once in a while the last digits are a little bit off here, because these values actually have been rounded on the table. But let's double check and see here if we do this with the calculator. So I have an area of 0.67. So I'm gonna go second, vars option 3. The area is 0.67. Notice that I have on this calculator that tail. On yours, especially if you have a calculator that you checked out from our library, it doesn't have that tail. It doesn't change, it doesn't have that line that has the tail. So it should always be a left tail. In this case, I have a choice, but I'm just gonna leave it as left tail. So I go to paste, press enter, enter again. And notice it is a little bit different. Oh, but you know why? It's because I did that. I put that wrong. It should be 0.67. It was close, but now that could be rounded. If I rounded to 2 decimal places, could be rounded to 0.44. So be careful with the tables here when you're doing that. Okay, so the next one, so this one was, so there are a couple of table ones, but let me go ahead and move on to another one. So here, this one is number 18. And this one is number 19. That requires a slightly different formula. So it talks about the concentration, the bicarbonate concentration or mean in a person's blood. And it says that the mean concentration is 120 milligrams per deciliter. So then that tells me that my mu is 120. It says, suppose that the distribution is normal with a standard deviation of 5.7. So the population standard deviation is sigma is 5.7. Then it says, if an individual is randomly selected, find the probability that that individual's concentration is between 120 and 122.1. So remember, when we're talking about an individual, that's an X. So we're looking for the probability that an X is between 120 and 122.1. And in order to do this, we have to change this to z-scores. So you have an X that is 120, an X that is 122.1. If this 120 is the same thing as the population, the population mean, then that means the z-score will be 0. But the formula that we're using is actually z equals x minus mu divided by the population standard deviation. So when I take 120 minus 120, this is going to give you a z-score of 0. Now, this one I do need to convert it. So that would be 122.1 minus 120 divided by 5.7. And this z-score is 0.36. So then this becomes the probability involving z-scores, that the z-score is between 0, and I meant to put a z, between 0 and 0.36. Okay, so when you're thinking about z-scores, A z-score is where the mean is, and that's a z-score of 0. And then a positive z-score of 0.36. I'm going to exaggerate this so we see it. It's to the right of 0. So here is the 0.36. And the probability will be the area that is is in between those values and under the curve. So I prefer to do this on the calculator, and this is actually second VARS choice number 2. And this is your lower limit, and this is your upper limit. So let's go to the calculator. Let me clear all of this. Let me clear that. So I have second VARS option 2. Then for my lower limit is actually a 0. My upper limit is 0.36. It is based on a population mean of 0 and a standard deviation of 1 because they're z-scores. Press enter. Enter again. And I get 0.1406. And I think this is actually continuing here. And they ask us to write it as a percent, so it will be 14.06. Okay, so for number 20, you do need some formulas. You need the standard error, E. It is based on the z-score that corresponds to that confidence of 90% times the population standard deviation, that sigma, divided by the square root of the sample. So we do need to think a little bit about how to find that z-score here because we need to figure out what the area is. So if your confidence interval, I'm going to run out of space here, so I'm going to do this. So your confidence is 0.90 and alpha is 1 minus 0.90, so it ends up being 0.10. You have to do this every time that you're looking for that z-score, and then you're going to divide that by 2, so that ends up being 0.05. And that is the area that we use in option 3 to find the z-score. So when I go in here, I go second VARS option 3. I put an area of 0.05. Let me double check. Yes, I had already divided it. We leave it at if you have that option of the tail, then just leave it always on left. Go down here, and this is gonna be the z-score, but the calculator thinks that you're using a negative value, And this should actually be a positive z-score in here. The area that we started, or the point, what is happening is the point 90 is the area in the middle. We're subtracting it from one and dividing it by half. But the calculator always think that you're talking about an area to the left, but this should really be a positive z-score. So we should use 1.644 into this formula here. Okay, the next one is let me see. Okay, so this next one here, number 21, in a way uses the same formula, except that you're looking for n. So you do still have to find your z-score. And here, E says that the sample, let's see. It says, how large does the sample have to be if the administrator wants the 95% confidence of finding whether the true mean differs from the sample by 0.5? So this 0.5 is actually your E. The standard deviation is the 2.5. You're looking for N, but you're going to find the z-score the same way that we did here by taking that 0.90, that confidence interval from 1, that gives you your alpha divided by 2, and then you find the z-score, but you're actually looking for N. Now, when we're talking about t-scores is because we don't actually have a standard deviation, so that's going to require different options on the calculator. So you have n equals 13, and you have the degrees of freedom that are always n minus 1. So in this case, it will be 12. You want an area. Notice you have that alpha equals 1, so you have C equals 0.95. Then alpha is 1 minus 0.95. So that gives you 0.05. But then your actual area that you put into the calculator is alpha divided by 2. So that will be 0.025. Or you can actually put it as divided, 0.05 divided by 2. Then it is second vars and option 4 to find a t-score. So I go second vars option 4, and it gives you an area. You could put the alpha, which is 0.05 divided by 2, or you could divide it ahead of time. The degrees of freedom in this case is actually a 12. Go down to paste, and that will find the T for you. And this one here, again, the calculator thinks that since you're getting such a small area, that is the area to the left, but this will actually be a positive t-score. So then that's going to be a 2.179. Okay, so here in this next question, and this one would actually be number 23, we are actually constructing the confidence interval. So we start out with the sample size, which is 26. Um, we It says suppose that a sample of 26 um, students in a particular college, they have the average number of credits being taken this semester is 11. So in that sample, that's X bar equals 11 with a sample standard deviation of three credits. Uh, then it talks about find a 99% confidence interval. So C is 0.99. And we need to find our area so we can find our t-score. So that's when you take 1 minus 0.99, and that gives me 0.01. Then the area that you put into the calculator is alpha divided by 2. And you can either divide it or you can say 0.01 divided by 2. Now, this part, I think this kind of problem in general, it's a little bit tricky because this is a sample. You don't really have the population standard deviation. So what you're looking for here is a t-score. When you do this, so that will be actually option 3 on the calculator. And you need the degrees of freedom. So if the sample size is 26, you subtract 1 and it'll be 25. So now we're going to find, with this information, we're going to find the t-score. So I have second bars option 4, and I have 0.01 divided by 2. And then I have degrees of freedom is 25. And again, make sure you pick a positive t-score for all this confidence intervals. In margins of error, your C-scores and T-scores are actually positive. It's just the way the calculator does that. So you have 2.787. Okay, so the margin of error, this is the formula. It's T times the sample standard deviation divided by the square root of n. I'm not going to calculate it because we're going to run out of time. But then you take the X bar minus E and the X bar plus E, and that's going to give you your lower limit of the confidence interval, and this is going to give you the upper limit. Sometimes they're given or you're asked to express them as an inequality sometimes. They say lower limit, upper limit. Okay, so this next series of questions, they all have to do with finding confidence intervals or related to confidence intervals. It could be the sample size, it could be the margin of error, but the formulas are all different. So I'm gonna, if I don't work them out, it's because I want to make sure that you have the formulas in when you work them out in here for practice. Okay, so that one would be number 24. So number 24 talks about a confidence interval for a proportion. So right there, we start out with the p hat. That's the sample proportion. and it's actually the population proportion over the sample size. And then the Q hat is 1 minus P. In this particular case, you don't have to calculate it this way because it's the point, the 38% is actually your P, but you need to identify that. Your margin of error, E, is based on a Z-score for proportions, but then you multiply by the square root of P hat times Q hat divided by N. And then the sample or the interval will be the P hat minus E and the P hat plus E. Okay, number 25 is actually talking about a kind of a similar situation, but it's asking you for the minimum sample size. So in a way, is this formula, but all turn around just to find the sample size. But we can write it as a formula. It will be N equals P hat times Q hat times the quantity that takes the Z-score divided by the margin of error and square. In the, you know, some problems tell you, oh, in the sample size, very good. I imagine that's what you're referring to. You always round up. Very good. Thank you. I had it on my notes. So I actually end up with, in this problem, I ended up with 602.27. In the rules for math will not round it up, but the sample size represents the number of households, so we always round it up. So this will be 603. So you round up class width and you round up sample size. Okay, so the next question, number 26. This is a confidence interval for a difference. So that's when we start seeing two samples. So you have a formula for the margin of error that is actually different. It's based on a Z-score, but it uses the standard deviation square, which is really the same thing as the variance, divided by the sample size for X, whatever the sample size is, it is right here. It doesn't really matter what you call X and what you call Y, because here they're sums. So just make sure you identified maybe the women are X and the men are Y. So now you have plus the sample size for the other sample, square, so that's really the variance, divided by the sample size for that particular sample. And then when you're talking about a confidence interval, now this is a little bit different. I'm gonna run out of space, so let me draw a line here. Since we are comparing two samples, you actually take Y bar, the mean for that sample minus X bar. You take that difference, and that's what you add or subtract the margin of error to get your lower and upper limit. Okay, number 27. So this one is talking about proportions, but two proportions. And it actually, hold on, let me see. Yeah, it's talking about a confidence interval for the difference between proportions. And again, that formula is also different. Now, I didn't write this one down separately as an error, but when you're calculating your confidence interval, you're taking the p hat for x minus the p hat for y. You don't have to put it in parentheses, but sometimes I like to see the parentheses, plus the margin of error, and the margin of error is based on the z-score. And this is actually very different. It is the p hat for x times 1 minus the p hat for x, by the way, that's q hat, divided by the sample size for x, plus, and now you have p hat for y, minus 1 minus p hat for y, that's actually q hat, divided by n, the sample size for that. So this is really your margin of error. I just don't have it as a separate formula in there. Now, there are a couple of other little formulas in here, which should have been, I should have written this ones before, because you're having to calculate the p hat for x, and the formula for that is you take the x amount plus 1 divided by the sample size for x plus 2. And then when you calculate the p hat for y, you take y, that y is getting deteriorated. That would be y plus 1 divided by the sample size for y plus 2. So you would actually calculate those before you can actually put it into the confidence interval. Okay, so the next couple of questions don't require a formula. And I'm gonna skip number 28, and I'm gonna look at number 29. So when they start asking for critical values are either z-scores or t-scores, and they could be found on the calculator. So if they say it's a two-tailed test where alpha is 0.10, remember, we always have alpha, but what's happening here is that alpha is actually on the ends. So that's why we take alpha divided by 2 and alpha divided by 2 as our area. So the area that we use on the calculator is alpha divided by 2, 0.10 divided by 2, or 0.05. But then when I do that, the calculator thinks I'm calculating just, or in particular, this z-score. And the truth is that for a two-tailed test, you have two z-scores. But let me show you what the calculator will do. So I go second bars option 3. I put an area of 0.05. Go down to the word paste, press enter, and the calculator is going to calculate only the negative z-score. But for a two-tailed test, you have two z-scores, and they're exactly the opposite of each other. So you really have that your critical values are positive and negative 1.64 for a two-tailed test. And this graph got cut off. And here, in fact, there's an extra page there. So I'm looking for a z-score that has that negative 1.64 or negative 1.65 rounded up. So they all look like they're two-tailed tests. And unfortunately, the one that is correct is cut off. But this last one here is the only one that has negative 1.65 and positive 1.65. So it should be that D. Okay, so let's see. I went through these problems and I didn't realize it was going to be so hard to keep track of the numbers, and they don't have numbers in here. So that was 29, so this one would be 30. Okay, so in number 30, yeah, this one is number 30. Is talking about a p-value, and it's also talking about rejecting the region. So I didn't do all the calculations, but I made some notes. So first of all, you need to enter this on the calculator and find X bar. I mean, you don't have to necessarily put it into the calculator, but you need to find out what is the average of that sample. Okay, that's your X bar. Then we need to actually think about the hypothesis here. It says the data, it says an average of 60 speeding tickets are issued. This data shows that the number of speeding tickets issued each year over the course of 1 month. They give us the standard deviation, population standard deviation is 13.25. Then it says, is there enough evidence to reject the reporter's claim at 0.05? So it sounds like the claim is that the average number of tickets is 60 degrees. So that's going to be actually your null hypothesis. Mu equals 60. And it looks like it's the claim. Then the alternative hypothesis, it doesn't say that it's greater or less than, so then we're going to say mu is not equal to 60. Now, this determines that we are looking at a two-tailed test, the alternative hypothesis, but I need to find my z-score using X bar minus mu, and there needs to be an adjustment for the standard deviation. So that's when you have a standard deviation divided by the square root of n. I didn't calculate it here because I was running out of time, but then so this is the z-score that corresponds to an area of alpha. And the p-score is 2 times alpha. So once you find that z-score, you need to find the area that corresponds to that to find the p-value. Then you're comparing the p-value to the actual confidence interval. And if the p-value is greater than the confidence interval, then we do not reject. If the p-value is less than that alpha, then we reject the null hypothesis. Since the claim was that they're equal and we are not rejecting the null hypothesis, then watch out for the wording here. It says there is or there is not enough evidence to reject the claim. And um, and we decided not to reject the claim. So we say there is uh, not enough evidence to reject. No, actually, um, we decided to reject, so there is enough evidence. Hmm. I think when it's greater than it says not, so we decided not to reject, so, and that is the claim, so there's not enough evidence. I'm hesitating because of the claim, but the claim is your H null, and we already decided that we cannot reject it, that we will not reject it. So there is not enough evidence to reject the claim, since the claim was H null. Okay, so now we're getting into some of those that were not, that did not appear in the first document, and you are having to find, you do have to find certain formulas here. I think I skipped one. I have it out of order actually. So in this one here, again, you need to find X bar. And in this case, since we're not given the population standard deviation, we actually need to find um, a t-score for our critical values. So we have that H null will be mu is actually equal to 110. And this does say that is there sufficient evidence that the average calorie is greater than 110? So that means the alternative hypothesis will say mu is greater than 110. This makes it a right tail test. So then the area, this is going to be a little bit different. We haven't seen that happen in too many places, but the area that I use is for a right tail test is actually 1 minus that, and I didn't mean to write it like that. It's the area, and it will be 1 minus alpha. So it will be 1 minus 0.05, so that will be 0.95. The degrees of freedom will be the sample size, which is 15 minus 1. And then this is how you find your critical value. With that option 4 of the calculator. Now, the test statistic, T, requires this formula. X bar minus mu divided by the sample standard deviation divided by the square root of n. And I didn't finish calculating this, but what happens is here is the critical value. This is called the rejection region. So the T, if the T happens to be here, then we fail to reject the null hypothesis. If the T happens to be in the rejection region, then we decide to reject it. So I skipped number 32 because it's similar. Number 33, it's going to be different in different formulas. This is when we start looking at two samples. So I'm gonna call this one. Let's see. And this two. So your null hypothesis says that the means, the sample means are actually equal to each other. So I have x1, x bar for sample 1 is equal to x bar for sample 2. So the alternative hypothesis will say the opposite, that they're not equal. So that makes it a two-tailed test. The reason why that is important is because the area is adjusted based on that. So this will be alpha divided by 2. So that will be 0.02 divided by 2. That will be 0.01. This is what you use, and the degrees of freedom will be, and you use the degrees of freedom for the first sample. I'm going to put a 1 here. So that will be 22 minus 1 equals 21. So then you use this with that option 4 on the calculator to find your critical values. Since it's a two-tailed test, you have two of them, is 2.5176. Now, the test statistic, this is what's also different here. The test statistic will take the difference of the sample means, so that will be x bar for sample 1 minus x bar for sample 2 minus the difference of the population means. However, this is always a 0. We don't even know what they are. So that always turns out to be 0. And then it's divided by the sample standard deviation for the first sample square, or the variance, that's the same thing. Be careful here because you're not given the standard deviation, you're given the variance. This is already the S square. And then plus now the sample standard deviation for the second sample square, or the variance divided by the sample size. And then depending on whether T is in the rejection regions or not, then you reject or fail to reject. Okay, I'm going to skip number 34. That's just writing your hypotheses. And because we do have some other formulas for number 35. So 35 is two samples, but based on proportions. So in this case, you have that 29% of men have diabetes, 30.5% of women have diabetes, and then a random sample is selected and the following results are obtained here. And then it says you conclude that a higher percent of women have diabetes. A lot of times it depends on how you word this. So if I make this my sample 1 and this my sample 2, then my null hypothesis is saying that P1 equals P2. But then my alternative hypothesis, I almost put an A in there. Sometimes you have options in here, and that's why I'm saying it depends on what you pick, but it really, you want to look at what options you're given. So in if I say women have a higher percent and I chose P1 to be men, then I want to say that P1 is less than P2 because P2 represents the women. So watch out when you're looking at your options here for that. Okay, so now this makes it a left tail test. So then that means the area will actually be just the alpha. And again, this is how you find your critical value, and it is a negative. When we're looking at confidence intervals, that z-score that we find is never a negative, but in here they could be negative because the critical values refer to rejection regions. Okay, so these are some formulas that you will need to find the sample proportion for P1, that's P hat. You divide X1 by N1. X1 is actually the number of people, the number of men with diabetes over the sample size. Then to find the sample proportion for P2, that's P hat, then you take X2 divided by N2. So that's the number of men with or women with diabetes. That's 51 over the sample size, which is 150. And you probably will turn them into decimals in there. Then you have the population proportion, and that will be X1 plus X2 divided by N1 plus N2. And you can find Q by taking 1 minus P. Then to find the standard statistic, which in this case is a z-score when we look at proportions, then you're taking the p hat for 1 minus the p hat for 2 minus the 1 p1 minus p2, and then this again should be 0 every time because we don't really know what the actual proportions are for the whole population. All of that divided by the square root of the P with the bar over it times the Q with the bar over it, and then 1 divided by N1 plus 1 divided by N2. I know this is a lot, but I wanted to make sure that you had the formulas on your note card. And so we are not able to work every single problem, but this way at least you have your formulas. I saw a question on the chat. Let me see. No, the p-value is double the area that you find. So it's not, in one of those problems, there were few, there only one, maybe two, where we had the p-value. So the p-value is always the area that corresponds to the z-score, double the area. Let me find it. Let me find the problem where we were doing number 30. One more. So you find the z-score with this formula, and then based on that z-score, you will actually use, I messed up. Let me quit that screen. You would go second bars once you know the z-score, you will go to this option 2. Let's see, option 2, and or use a table to find the actual area for the z-score that corresponds to the z-score. And then the p-score is double that, whatever this area is. And maybe I shouldn't call it alpha because I think maybe that's confusing you there. So then you compare it to alpha. So this would be the area corresponding to the z-score. So once you find that area, then you double it. Any other questions? Okay, so don't forget, don't disconnect because I'm gonna go ahead and go to participants and take a picture of it, and based on that, in my previous one, then I will give you credit for your attendance.
My camera isn't working.
Okay, okay, Noah, it's the end. I will forgive you for that, but it is one of the rules for the Zoom meetings, but it's all right. Thank you for letting me know. Any other questions? Okay. I'm gonna disconnect and I'm gonna post, as soon as I get the link, I'm gonna actually post this recording. I posted in the same blog where the final exam is, the same module. Okay? Okay, have a good day. Good evening.